Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is 48 volt mild hybrid systems operation and testing. And that's kind of a mouthful, but this takes me back to, say, the end of last year. So I was researching some information on batteries and charging systems, starting systems, because we were doing a class on that. And I wanted to put in a few slides on the 48 volt mild hybrid vehicles. And I did not realize at the time how many vehicles are out there that have these type of systems running on them nowadays, and actually how long they've been around. So they've been around for quite some time now. So we're going to get into the difference, couple of the different ways that a couple of manufacturers do it. Then we'll walk through on the tool, the information that you can find and the different scanner functions that you'll be using testing these. You may have to do some resets and relearns as well. So we'll talk through that. But first, we need to start at the source, the battery, right? So we're used to the normal 12 volt battery on a vehicle, lead acid battery, and of course stores electricity to be used later on the vehicle. Mainly used to start the vehicle. Once it's running, it'll help supply power to the accessories in conjunction with the alternator, of course, and provides that 12 volt source that we're all so used to nowadays. Started with 6 volts, but now we're on 12 volts. We have the three main types. We have of course, our lead acid, which is the most common one probably. Runs in a acid bath, some lead plates. AGM, which is absorbent glass mat. And then we have our lithium ion batteries, our lithium polymer batteries that are often used, especially in these 48 volt systems on these vehicles. So lead acid batteries, as I said, they use those lead plates in a bath of sulfuric acid. So the difference in lead compounds allows ions to transfer between the negative and the positive plates on the inside the battery. You can see we got different lead plates in there with different electrode in there. Voltage per cell, if I were to measure just cell by cell, should be 2.2 volts. It adds up being a little over 12 volts, but 12.6, right? Or so voltage in there. So it should be 2.2 volts per cell, adds up to a little over 12 volts when we have that. We also have AGM batteries, which would be glass mat absorbent. Glass mat is what that stands for. So it's essentially a lead acid battery, but it has these absorbent mats in between the plates to make it so it doesn't slosh around. So they use these an awful lot in race cars and things like that, so they don't have the electrolyte sloshing around, and also so it doesn't spill. So if that's a lot safer that way, so it doesn't spill out because it's absorbed in the mats themselves. And then we have the lithium polymer batteries or lithium ion batteries. They use that lithium ion technology, and commonly these are the ones that are used in these 48 volt systems. Of course, we have lithium ion batteries in hybrid cars and electric vehicles too, but these 48 volt batteries are used most often in these mild hybrid vehicles. Now, mild hybrid, what they're used for, it's going to give a small assist to the engine, helps increase miles per gallon, also works with the stop-start system. So mild hybrid vehicles use a hybrid style generator to charge at 48 volts DC. And they also will have a DC to DC converter on them used to charge the 12-volt battery and run the 48-volt systems as well. So it is as it says, a mild hybrid. So it's really talking more about it's a hybrid electrical system. So I remember back in the shop when we were working there, and everybody was saying, "Oh yeah, they're going to change the. We're not going to be doing 12 volts anymore in the industry. Everybody's going to 48 volts because of all the electronics on the cars. We need the more voltage, so everybody's just going to go to straight 48-volt system." And as we can see now in the future, because we're in the future from there, didn't happen. But what they were most likely referring to was companies were coming up with 48-volt technology to use in this way. So the 48-volt system is designed to support heavier load components like the air conditioner and the engine fan, and also enable faster heating of the cabin and catalytic converter at startup. We have the lithium battery, of course, in this case, AC to DC converter, because the generators on these also run 3-phase AC usually, not always, but usually. Hybrid controller also gives you more power for takeoff. So a 48-volt battery can supply more power to the hybrid motor and supercharger, launching the car faster and smoother than a traditional 12-volt system while still saving fuel. So they are electric supercharger, turbocharger, don't really know how you want to call it. It looks a lot like a turbo, but it's an electric turbo. So instead of running off exhaust, it runs off the electricity. Also, you have a generator, air conditioning usually runs off it, and then we'll also have a DC to DC converter. We have 4 times the power available, which enables an intelligent driving experience, improving efficiency and providing power from more accessories such as active safety and connected infotainment systems. We have rolling computers rolling down the road at this point in our lives, right? So 12-volt battery, and also has a 12-volt standard electrical distribution center that you would be used to run the radio and the lights and all that other stuff on the car. Also, to control all of this, you will have a battery management system. So most manufacturers nowadays, whether it's 48 volts or not, will probably have some sort of battery management. It allows it to change the charge rate of the battery based on the state of charge of the battery, state of health of the battery. Uses sensors, controllers, and software to monitor it. It allows the vehicle to charge the battery depending on what the load is, what the state of health is. And when the battery is replaced, the system usually needs to be reset. Usually with a scan tool, I actually have to go into the module, reset the system, tell it that a new battery has been installed, or that some sort of work has been done to the system to allow it to reset, recalibrate itself. So let's look at a few different manufacturers and how they approach it. So the first one's going to be CDJR, so Chrysler, Dodge, Jeep, Ram, Fiat, whoever. However they put this out there. So on these vehicles, they're fairly simple. I think it's kind of an interesting way that they took this approach. So you have a battery management plus battery in behind the cab here. That's on a pickup. On other vehicles, it'll be probably obviously in a different spot, but we got our high voltage wires here in the middle, and then we have our generator starter assembly. We take a look at how this works, or how this would look on the vehicle. This one over here on the left's the 5.7 V8, the Hemi. So you see it looks like just a giant alternator on top of this engine. And then it also has this computer pack and a bunch of battery managements built in right here. Big old heat sinks and everything. So this is used to generate the 48 volts for one thing. But it is also used in the start-stop system on the vehicle. So the starter itself is only used to start the vehicle the first time. Then once it's running, this takes over and it generates enough torque to crank the engine over when the start-stop system works. This one over here is on the 3.6 motor, the V6, and you see how it's kind of backwards. So the pulley's in here in the middle, and then this is the back side of that with it. So it's just kind of interesting how they decided to do that with a giant alternator looking thing. It's not really an alternator, it's a generator, right? They call it ETorq is their marketing term for that. So it allows it to do the start stop. It also can provide a boost on the low end, like off the line. It gives us a little extra so we can get up to speed easier with using less fuel. It's all looped around using less fuel. So the ETorq system automatically stops and starts the engine when certain conditions are met to improve fuel economy and lower carbon dioxide emissions. The ETorq enable and disable selection switch is integral to the transmission shifter. You can actually turn it on and off with the shifter. The battery starting and charging systems operate in conjunction with one another and must be tested as a complete system. That is an important sentence right there. So they work in conjunction with each other and must be tested as a complete system. So if I think one thing has failed, the battery, the starter, the charging system, I need to test it all, knowing that they interoperate with each other. So that is good to know. I mean, yeah, on a normal non-48 volt vehicle, they do work in conjunction with each other as well, but not as close as you would see on these 48 volt hybrid systems. For correct operation of starting and charging systems, all components used in these three systems must perform within specifications. When attempting to diagnose any of these systems, it's important that you keep their interdependency in mind. Certain starting system components and functions of the ETorq system are onboard diagnostic monitored and will produce a diagnostic trouble code. The use of the diagnostic scan tool is not only recommended, but it is necessary for proper diagnostics of the ETorq system and the components or systems that are related to ETorq system functions. In short, if you want to work on these vehicles, you need a scan tool that can get in and help you test these and perform functions on there. Otherwise, you're not gonna be able to do it. The ETorq system uses a high torque electric 48 volt motor to function as a starter for electric stop start. The ETorq system, when active, will shut the engine off with a signal from the PCM when the vehicle is stopped, then start the engine when there is a demand for power. The ETorq system utilizes its own contained cooling system. For more information, see this article. The vehicle's first engine crank event is managed by the driver starting the vehicle normally with the key or the start-stop button. During the initial start, the PCM cranking relay is open and the PCM cranking relay is closed. And that just tells you a little bit more about the relays and such down through here. I'm not going to read through the whole thing, but just note that you need to keep this in mind as well. On these particular vehicles where they have a starter and they have a generator starter, when do I have a no start issue? If I have a no start issue, when does it happen? Does it happen at first startup? If it happens at first startup, then I know I need to look at that starter. If it starts up fine and then I'm driving down the road, I get to a stop sign, it shuts off and it doesn't start back up, then I know I need to look into the starter generator system, right? So the main starter wouldn't necessarily be the issue in that particular case, right? So you need to understand how the systems work in order to diagnose it properly, which is what I always preach here anyway. Understand how it works, and it'll be a lot easier to diagnose. So motor generator unit here. So 3.6 liter has a liquid cooled motor generator unit. It's a hybrid control processor integral into the motor generator unit and is not serviced separately and must be replaced with a motor generator unit. So if you have a problem anywhere in that system, got to replace the whole thing. It is flash programmable and sensitive to cold temperature during module flashing. The hybrid control processor will need to be flashed when the vehicle is at room temperature. Good to know. Failure to flash the module at room temperature can cause the flash procedure to not complete, which could suggest an unnecessary MGU component replacement. Okay, go a little further. Power pack unit. So this is the one that was behind the seat there, in front of the bed. So the PPU is power pack unit. It's a 48 volt battery pack with an integrated DC to DC converter and battery pack control module that supplies voltage for the electric stop start system to start the engine during an electric stop start event. 48 volt battery can also supply voltage to the 12 volt system when needed by way of its internal 48 volt to 12 volt DC to DC converter. The PPU on the vehicle is air cooled using an internal dual fan assembly that circulates cabin air through the PPU. Dual fan assembly is serviced as an assembly with the PPU. PPU has a 12 volt and 48 volt connection to it to allow for charging of the two different voltage systems. PPU is only serviced for replacement as an entire assembly. Once again, no user serviceable parts inside. We have to replace the whole thing as a unit. And then once again, the starter motor is only used once per ignition cycle. After the initial start of the motor generator unit is responsible for all engine restarts during stop events in the ignition cycle. Now, once I turn off the vehicle, once I cycle the ignition off, then of course, the next time I start it, that'll be the regular starter. But just understand when I'm trying to diagnose, especially a no start, we need to understand that. And once again, the different components of the system, we have the motor generator unit on the front there. We have the high voltage wires, and then we have the power pack in the back. And that's just on this particular Ram. Looks like it's a V6 because it's got the backwards. Now we'll get into a different style, which is going to be Mercedes-Benz. So Mercedes has this in a selection of their vehicles. And instead of using an external generator, they have an internal starter generator control unit here, kind of in between the engine and the transmission. So it allows it to help. So we can see here's kind of a cutaway of that, and they call it EQ boost is their way they call it. And notice also on this here, we have a beltless engine. Beltless engine. So any accessories that would normally run off a belt are no longer running off a belt. They're running off voltage inside the vehicle. So we have an electric AC compressor, an electric water pump. Unless it's integral in here somewhere, it's going to be an electric water pump. So we have all of those now beltless engines. So I guess that's kind of nice. You don't have to worry about ever replacing a cert belt on this thing, but it makes it far more complex for sure. And then here's the assembly mounted at the back of the engine, right? You can see a couple cylinders there. And then you can see the this is the whole unit here, the motor starter generator unit there. So generating operating principle, the hybrid system is explained in the following. The generate the drive torque, one of the following is used: only the combustion engine, only the electric machine, or the electric machine in combination with the electric engine. It's a combination mode. In hybrid mode, the electric machine and combustion engine work together in the powertrain, which aggregates the torques of the individual drives. The electric machine generates either an engine-generated torque or works as an alternator and recuperation. Control of the hybrid system comprises the control of the combustion engines and the control of power electronics control unit with the electric machine. The master control unit is thus the powertrain control unit, which contains the aggregate coordinator. There's a lot of engineering speak in there. But just it can run either just the engine, just the electric, or a combo between the electric and the whatever. So that's how they work it. So it's kind of like a hybrid vehicle almost, where it has that integrated starter generator. And also it does not have a separate starter on these vehicles as well. So it is using that to start the engine, uses the torque from that unit to actually start the engine. Now we get to GM. GM is one of the OGs to this system as well. We'll talk about that in a minute, but GM's been doing this a lot longer than you may think. So they call it eAssist, is what their marketing term for it is. And it consists of a motor generator and a power pack with all the electronics and the battery, and everything is assembled in this one power pack. Usually it's mounted in the trunk. And we'll see they kind of went along with the same type of thing that CDJR did. So we have the battery pack here. We have a service port. We have the high voltage lines going down to the generator assembly and starter assembly again. So this does the same thing. So it does the start stop. It uses the generator to do that. Now look at how much belt tensioning and idling and stuff needs to be done in order to make that happen, in order to crank that engine over, put enough torque on that. This is a V8, I think, pretty sure it's a 5.3. So be able to torque that engine over. Now that is the nice thing about electric motors. It is, it's a lot of torque to go on with that. So that's how GM does it. And it's been around since 08. So what are we in? 23 now? So that's 15 years. GM's been using this, some form of system, in order to make these things go. So here's an example on the ETorq 2.4, the LUK engine code. If you're a GM person, you'd understand what that is. But so there's a starter motor generator there. We can see lots of pulleys and such. In this one, it is a belt powered AC compressor. So remember how some systems will run it off the high volts. In this case, this system runs it off the belt. So we have one common belt that runs the generator, starter, and then the AC pulley down here, and so on. So the ETorq. So that's the first generation, was in 08. Second generation began in 2012, and then Gen 3 began in 2016 when they started putting them on the trucks as well. So that's 16. That's still, 7 years ago. So they've been around for a lot longer than you may have thought that they have. So in this case, the Buick Regal right there. So let's look at a couple things we can see as far as between repair information and then also things that we can do with the scanner. So first one I have pulled up here is a 19 Mercedes-Benz CLS, because that has that system on there. I'm going to go into repair information. So it's a CLS 450 with a 3-liter, and it has this EQ system on it as well. So first thing I want to look up is the generator, because it is a generator, right? So pull that up, and we'll go to generator here, and we can see, actually I want to do generator start. No, we'll just go to generator. So OEM test procedures, component locations, component operation. All right, so it's going to tell you, it kind of puts it under alternator, but it's the same 48-volt technology, right? So there's the control unit there where it's located. It's equipped with a power electronics unit, which sets up connection to a 3-phase AC system. Like we said, three-phase AC there. Wiring diagrams. So wiring diagrams, it does have the AC circuit in there as well, because there's an electric AC pump, but I want to go to charging and starting. And then if we look at the charging circuit, take a little bit better view of this, you can see that there is the starter generator control unit right here with all its signals. And then we have the direct connection over to the actual integrated starter generator inside, between in the bell housing. There also is a onboard electrical system battery there as well, to have that to help us with other things in the vehicle. And then we also have the starter is integral with that as well. So we don't have a separate starter there with that system. Because we look at the charging circuit and the starting circuit, boy, they pretty much look the same, right? Other than it has a start-stop button right there and ignition switch. So other than that, they are laid out the same, because they're integrated with each other. Right? So we can talk about OEM testing as well. So what can we test on this? Really, what you're going to be testing physically is going to be, there's maybe a gap between the stator and the rotor, which it gives you a spec there. And then we have resistance readings. So we'll use a meter and check the resistance between the 3 phases. So actually there's 6 phases on this vehicle. So we have UV, W, and XYZ. So there's 2 different phases there. It actually gives us a picture down here as well. So there's a picture of what that looks like. This is on the side of the motor assembly there with the cover off. So we can see XYZ and UVW here are the 6 phases that it has. Or it's really a 3-phase motor. I'm pretty sure it's probably in and out, but yes. So if we have any problems with that, the overall resistance will increase or decrease. If the measurement values are outside of tolerance, replace the whole darn thing. So there's, once again, no user serviceable parts inside. We can just go in and we can, non-serviceable, we can just replace it. Replace the whole thing. So that's the information on there. Let's go into Scanner and see what we can find in here. So we'll pull up this. And in this case, we need to go to, everything's categorized, right? So we got comment selections and so on. So we got to go down to H for hybrid and electric vehicle information. So we can see battery management, charger, sound generator as well. We have starter, alternator, 48-volt electrical system. So we'll go into the system. Now, there's a lot of different variants on this. I'm just going to pick the first integrated starter generator thing we have. As far as data, temperature, system information, learning process, we can find the data on that. Functional tests, though, there's a special function in there for teaching in the starter alternator control unit. So if you have to replace this unit, you have to do this teach-in of the component. And of course, I'm on a simulator, so it's not going to let me in, but you have to do this teach-in process. It'll walk you through what you need to do with the scan tool in order to do that. So that's the starter generator. Go down to battery management system. So like I said, most vehicles are going to have this battery management system in there. Different functions we can do: isolation measurements, high voltage component lock, I guess, actuator test, interlock circuit, different data in here. So we can see the high voltage battery cells, cooling, isolation, etc. So like I said, a lot of the things that you would do with this, you're not going to be testing it directly, except for that resistance measurement we saw. You're going to be using data and functional tests in order to test these vehicles and to work on these 48-volt systems on here. All right, so that's the Mercedes. Let's go and look at Ram, because we know that's a little bit different, right? So we'll go into Ram, and we'll just call it a Bighorn. Gonna load in. Once again, we'll do generator. Generator replace. And then we can come down here, look at the wiring diagrams on this thing. Once again, starting charging system with ETorq. You can see we have a regular battery. Actually, we'll just go down to the starting. Oh, I guess it is just this. All right. We come in here, and we can see we got the battery goes to the actual starter itself, and that's it. It goes to the power supply, and it goes to the starter. Other than that, we have an intelligent battery sensor as well. But then we have down here, we have the battery pack control module back there, and then we have the generator module right here. So it gets a crankshaft. Let's see, it gets a couple buses, CAN bus, FSD bus, crankshaft pulse signal, FSD ignition, etc. So there's a bunch of different signals that it does, and a 48-volt in over here from the battery pack. Powertrain control module there. So not a lot going on because a lot of it's integrated with this power pack. Let's look at some remove and replace, right? So I picked the 3.6 liter. So just some inspection notice on there. Let's look at the actual parts and labor on it. So remove and replace with the motor generator unit includes programming 2.6 hours. And then the alternator, generator, starter, whatever you want to call it, $968 from the manufacturer. So that's $1,000 alternator starter. So you want to make very much sure that it's actually working or not working when you do that. Another interesting thing I found in here. Oh, yes, behind security link too, because it's a 2020. Okay. So on this, we have battery pack control module. And miscellaneous functions in here. So we have battery isolation test, isolation fault, reset high voltage impact event. So if you have an accident, you need to go in there and reset it. You can do a replacement function, etc. And then if I go into the hybrid control system, right there. There is a random function in here. It's called belt capacity adaptation reset. So what this is that you only need to run it if it's you have either of these two codes. So I was interested to see what in the world is this code here. So I'm just going to do a little copy paste here. So I'll go in here, I'll go one search, plug this in here, set clear it. There we go. Plug that code in there. And what is this code? So this code is the motor generator unit has a hybrid control processor built into it. ACP provides a strategy for charging 12-volt power pack. Monitors 48-volt system as well. It monitors belt slip speed by comparing the hybrid control pack resolver speed and the crankshaft speed inputs and determines a belt slip condition. So if the belt slips, it'll set a code. So if my belt wears out, it sets a code now. And then we go and we replace the belt, see if the belt's bad. If the belt's bad, we replace it. Easy enough, right? And then you just have to go in and perform that test, the belt capacity adaptation reset routine. And if any repairs are performed on the 17 belt or 17 belt tensioner, perform the belt capacity adaptation reset routine, and then erase the codes. So when I replace the belt, I need to do a reset on a Dodge Ram. Okay, and then the last one we'll go to is this GMC. Similar type system, right? So don't really need to bore you with wiring diagrams, I guess, unless you like that sort of thing. Then if that's the case, then I apologize for not going into the wiring diagrams. But we have two powertrain control modules. They will do different things. So in this case, we have auto start, auto stop, ICE only mode. So that's internal combustion engine only mode. So it'll allow us to do some testing that way. Onboard jump assist counter, drive motor coolant pump relay. Oh yeah, transmission accumulator solenoid valve. Why is this in with the hybrid system? Well, in order to take off from a stop, If my engine's not running, what else isn't running? It's an automatic transmission. The torque converter's not moving, so my pump's not moving. And we have an accumulator solenoid to allow us to accumulate fluid and pressure so we can shift and we can go right off the line. So if we don't have any fluid moving, it allows us to accumulate that. So that's what that's for. That's cute, nice little fun fact, I guess. As far as data, right? Start stop data, because that's mainly what it does, is controls that start stop vehicle or vehicle start stop. So there is a ton of data in here. I mean, modern vehicles, man, the last 5 years, it's just data overload, right? Auto start reasons, or uh, reasons it's disabled, yes or no. All right, it's kind of crazy the amount of information, amount of data that you could, if you wanted to, pour over all this data um, on a vehicle. It's just kind of mind-boggling how much is available to you there. So it's definitely support in the tool for these systems. There's definitely tons of information out there. You just got to know where to look. Make sure you have the right vehicle loaded, I guess, would be the key point there. And they're out there, right? I only chose 3 different manufacturers because they're kind of the more popular ones, I guess. But like you saw, Mercedes, CDJR, GM, ton of different GM ones. I know, Hyundai has some, Kia has some by default with that. Bunch of different manufacturers using this type of 48-volt mild hybrid type system. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week, have a good night, and take care.